And what we're next going to talk about is the MUF scheduler, or the maximum urgency first, okay? And we can see here that the maximum urgency first scheduler is in fact a preemptive mixed priority scheduler. In other words, it uses both static and dynamic priorities. Again, it's a uniprocessor scheduling algorithm, and we are going to make the same assumption that we always make, which is relative deadline of the task is equal to its period. Again, that means that if you start at this point, the next release time is the deadline when you have to get done, okay? Now, the policy is based on three things. There's the urgency, or the total urgency, right, is based on criticality, which is just a binary number, laxity, which is a continuous dynamic priority, and then a user priority. This allows users to make decisions again between ties. And the continuous criticality is basically rate monotonic order. In other words, if we use the priorities like RMA, if we set them like RMA, then we'll get, when we have a criticality that is binary, we can also use a continuous criticality measure, but that's just going to give you the equivalent of RMA. This is how MUF is different. Now, first, we order the tasks in rate monotonic order. In other words, from the fastest task down to the slowest task. And again, rate monotonic, so the priority, or the criticality in this case, is going to be based on that set of tasks, but we're going to set what we call a critical task list, okay? These are the n fastest tasks that consume less than or equal to 100% of the CPU. So, in our previous example, where we had 3 tasks consuming a total of 96% of the CPU, all 3 of them are going to be in the critical task set. In other words, those values are going to be set to 1. All other tasks are going to be set, the criticality is going to be set to 0. Again, in our simple example with only 3 tasks, 1, 2, and 3, right, all 3 of those fast tasks, and are going to be in the critical set. There's nothing in the non-critical set. But imagine if we added a 4th task, okay, and the 4th task, say, had a period of 15 milliseconds. Remember, the fastest one had a 2 millisecond time. The second fastest had a 3 millisecond time. The third fastest had a 10 millisecond time. Now, this 4th task we're adding is 15 milliseconds, so it's the slowest. Ranked in RMA order, it's 1, 2, 3, 4. But 96%. If that task, let's say it's 10%, it runs for 1.5 milliseconds, we're going to have a problem. You're asking for more than 100% of the CPU, okay? Now, those first 3 are going to be in the critical set. The last one is not going to be in the critical set. And that's going to let us see what happens when we use the MUF scheduler in what in this case is an over-prescribed scenario. Remember, it's a lot like a transient overload. And we could say the same thing about a task that is exceeding its deadlines. The key is all these others, right? The laxity, we are then going to know the critical tasks are never going to get starved. They'll always be the highest priority tasks. And that critical task set, even when we ask too much of the CPU, those critical tasks are still going to execute. And that's what's different about our earliest deadline first. We do not know which one is going to cause a missed deadline. Okay? And we could do an example of that with our EDF, just to give you an example. But first, let's think about this MUF, that if instead of just setting criticality, we set it to the order, well, then that's going to be an RMA scheduler, right? Instead, when we set criticality to either 1 or 0, what we're going to do is our laxity is going to be the dynamic priority element among those most critical tasks. And then user priorities are going to allow you to pick only when there's a tie to be broken. And again, with EDF or MLF, earliest deadline first or minimum laxity first, either one of those, they're going to schedule 100% bound. Okay? And the ties don't matter in that case because the laxity, whether it's a tie in laxity or tie in deadline, it's still going to work. Okay? So, again, policy is the same. Always preempt a lower urgency task when a higher urgency task is ready.